In today's class, we'll go through some notes that are important in this chapter, which may be asked as give reasons to you. So, first point being the rubber band changes its shape on stretching. So, is it a solid? Because we know that solid have definite shapes and definite volumes, but it changes the shape on stretching. So why does this happen? Is it a solid? So the answer goes like this. A rubber band changes shape under force and regains the same shape when the force is removed. If excessive force is applied, then it breaks. Hence, it is a solid because it regains its shape whenever we leave it. So you can give the similar argument for a rubber that deforms its shape, or you can give it for a spring which on pressing changes its shape, but as soon as that force is removed, what happens is it regains its shape. So you can give the same reasoning for rubber band or even for a spring. The second point, sugar and salt kept in different jars take the shape of the jar. But we know that a substance that takes shape of the container, those are liquids and liquids. But why does sugar and salt take shape of the jar? So are they solids or not? So are they solid? So for sugar and salt, what happens is when we see at just one individual sugar or salt, whenever we keep it in any jar, that individual particle of sugar or salt remains the same. It does not change its shape or size. The crystal remains fixed. So as individually, if we see that they remain fixed, that is why it is a solid and it is not a liquid. So the shape of each individual, so basically they have definite shape. They take the shape of the container because the container is much bigger as compared to individual particles, and the individual particles of sugar or salt, they do not change their shape. Their shape remains fixed. So the shape of each individual sugar or salt crystal remains fixed whether we take it in our hand put it in a plate, or in a jar. Hence, they are solid. Okay. So sugar and salt, they take the shape of the jar. They are solid. This we understood. Now, similar arguments can be given for, like, you can say for pulses. We have pulses when kept in a jar. It takes the shape of the jar. You can have the exact same reason for pulses or any sort of dal that we keep in containers. The third type of problem that you may have over here is of a sponge. A sponge, though it is solid, it changes its shape whenever we press it. So why does that happen? A sponge compresses on applying pressure. Is it a solid? Question mark. So the reason for sponge is that sponge has minute holes in it in which air is trapped. So whenever we press it, what happens is that air that is trapped inside those holes come out of the holes. So actually it's a solid, but on pressing what happens is when the air is expelled out, when the air comes out, it compresses. So the solid remains intact. What comes out is the gas, that is the air. So it is a solid. A sponge has minute holes in which air is trapped. When we press it, the air is expelled out and we are able to compress it. Yes, it is a solid. The fourth note, there are a number of notes that we are taking. All this may be asked as give reasons in your questions or may be asked in a general sense as well. So the fourth note is that all living creatures need to breathe for survival. And what element that we need for our survival is oxygen. Now, those animals that are terrestrial, that live on the land, can get oxygen from air. But those animals that live underwater, how do they get oxygen? So those that live underwater need to derive oxygen from the water itself. So there is some amount of oxygen, a gas that is dissolved in liquid. So we can say that gases also dissolve in liquid. So the aquatic animals can breathe underwater due to the presence of dissolved oxygen in water. Thus, we may conclude that solids, as like sugar, dissolves in water, liquids, alcohol, say, dissolves in water, or we can mix oil and kerosene. So like dissolves like. So liquids can mix with other liquids, and gases, like for a good example of gases dissolved in water is oxygen, and another example is carbonated drinks like that of 7-Up or Coca-Cola that we drink, has basically carbon dioxide dissolved in water. So gases can also be dissolved in water, can be diffused, into liquids. Number 5th, okay, if you look at a solid or liquid that dissolves in liquid, say if you take solid sugar and try to dissolve that in water, it takes some time and a lot of stirring to mix that in water. But if you take a sugar syrup, and say a liquid dissolving in liquid, it will dissolve very fast in an instant, just once you stir it and it's mixed already. So the rate of diffusion of liquids is higher than that of solids. Okay, this is due to the fact that in liquid state, so when we consider a liquid, what happens is that in liquid the molecules are much further apart. So as they have greater space between each other, so they can move more freely. That is why liquid dissolves more freely in another liquid. This is due to the fact that in liquid state, particles move freely and have greater space between each other as compared to particles in the solid state. Number 6. Okay. We have a point over here in solid, liquid and gases that solids cannot be compressed. Liquid can be compressed to a certain extent, not too much, but a little we can compress it. And gases can be compared to a great extent, or it can be easily compressed. So how can we apply this? So you must have heard of LPG, that is liquefied petroleum gas, and CNG, that is compressed and natural gas. LPG is used as gas cylinders that we use in our home, and CNG is used in many automobiles as a fuel. So our point is here is that CNG is used as fuel these days in vehicles, due to its high compressibility. Now, how does this high compressibility help us? So, if it's highly compressible, what happens is large volumes of a gas can be compressed into a small cylinder and transported easily. So this is why it's important, the LPG and CNG that we use in our daily life. This is a one good example and application at the same time of the compressibility of gases, high compressibility of gases. Okay, number 7th point, and this will be our last point. So we know that when food is being cooked, we know that when food is being cooked, we can smell the food even without entering the kitchen. Why does this happen? Okay. See, we saw over here that liquids dissolve highly in liquids because it has spaces between them. Now consider gases. Liquids have little space between them, but gases, they have so much space between them. So they can diffuse even much faster as compared to liquid because of the space and its random motion. That is why when we cook food, what happens is the aroma of the food, it diffuses into the gases, the air that is present around us, and slowly travels throughout the house and even outside sometimes. So with the help of which we can judge what food is being cooked even without entering the kitchen. So the particles of the aroma of food mix with the particles of air spread from the kitchen and it reaches us and even sometimes more further away. And the smell of cold food and the smell of hot food, you'll get the smell of hot food very quickly as compared to that of cold food, is because hot, when a food is hot, what happens is it has more energy. Hot is related to heat energy. Whenever there is more heat energy, so with more heat energy there is more kinetic energy. The heat energy results in higher kinetic energy, and that higher kinetic energy results in more random movement. So as there is more random movement of gaseous particles, what happens is the smell of hot cooked food reaches us in seconds. Thus, the smell of hot cooked food reaches us in seconds. Okay. So the next topic is how matter changes its state. So there are two changes that affect the change in state. One of them is the effect of change of temperature. So if we change the temperature, what happens is the state changes. Now, why is that so? This explanation is given according to the kinetic model. Why do we say this as the kinetic model? Because with change in temperature, as we have discussed earlier as well, what happens is with change in temperature, heat energy is gained or lost. So if heat energy is gained, if we increase the temperature, heat energy is gained, and increase in heat energy results in the increase in kinetic energy. So that is why we say the kinetic model, and with increase in kinetic energy, what happens is the movement increases, and because of that increase in movement, what happens is there is change in the state. Okay, let's discuss how. So effect of change of temperature. On increasing the temperature of solids or liquids. Okay, I am writing it in this way because whenever I give a slash from here on, the first word will denote for solid, and the second word, whenever we have a slash like this, will denote for liquids. So on increases the temperature of solids, the kinetic energy of the particles increases. Now, due to the increase in kinetic energy, the particles start moving, or a much better term would be start vibrating with a greater speed. The energy supplied. So if we are raising the temperature, what is happening is we are providing heat energy. So this heat energy, the energy supplied by heat, overcomes the force of attraction between the particles. The particles leave their fixed position and start moving more freely. A stage is reached when the solid or the liquid. So if we write solid over here, we'll write solid over here. If we write liquid, then liquid over here. So a stage is reached when the solid is converted into liquid and the liquid is converted into a gas at the atmospheric pressure at a fixed temperature So we'll write now some points over here relating to this. Okay, this is a kinetic model of how solid converts into liquid or liquid converts into gas. So to explain this a little more, let's look at this diagrams. So suppose we consider this solid. So solids are very closely packed. So if we supply energy, what happens is the two adjacent molecules, they were vibrating earlier, now they start vibrating with much more intensity. So as the intensity keeps on increasing, what happens is this space will not be enough to hold the solid together. So with more and more energy, they will break free of this closely packed structure and they will convert into liquids. And this happens with the supply of energy as heat. So the temperature at which a solid melts to become liquid at the atmospheric pressure is called its melting point. And the temperature at which a liquid starts boiling at the atmospheric pressure is known as boiling point. Okay. Notes again. First point is that the melting point of ice is 273.16 Kelvin. The process of melting change of solid into liquid is also called, or is also known as, fusion. And the second and very important note, what happens at the melting point is that, suppose we consider ice. So ice is at 0 degree centigrade. When we supply heat, what happens is ice melts into water. But that conversion from the ice to water takes place at a fixed temperature. Now what happens? There is supply of energy, but the temperature is not changing of that of ice. So where does this heat energy go? So let's talk about this now. The heat energy absorbed by ice without showing any rise in temperature is considered that it gets hidden into contents of the beaker, that is basically the ice, and is known as latent heat. So whenever we supply heat energy, ice that was at 0 degree centigrade, as it converts into liquid, that energy is absorbed by the contents of the beaker, that is basically the ice. The ice is absorbing the heat energy, and since we cannot see any rise in temperature, we say that this absorption of heat is hidden. So as this is hidden, we call it as latent heat. The word latent itself means hidden. The word latent means hidden. The amount of heat energy that is required to change one kg of a solid into liquid at atmospheric pressure at its melting point is known as the latent heat of fusion. Okay, this is the formal definition for latent heat of fusion. The amount of heat energy that is required to change 1 kg of solid into liquid at atmospheric pressure at its melting point is known as the latent heat of fusion. Why fusion? Because this is melting. Melting is also known as fusion. So we conclude that since by absorbing heat energy it converts into water, so water at 0, same amount of water at 0 degree centigrade and same amount of ice at 0 degree centigrade. To convert from ice to water, it absorbs heat energy. So the more energy will be with the water in terms of heat if we talk about. So particles in water at 0 degree centigrade have more energy as compared to particles in ice at the same temperature. Okay, please mark this point important, and also this kinetic model. This is also very important. Here you may be asked question in 2 or 3 different ways. The first one can be this directly asking this latent heat of fusion, define latent heat of fusion. The second one could be that where does the heat energy go when we heat the solid to convert it into liquid. So you need to explain the latent heat of fusion. And the third one, it can be asked that what contains more energy, water at 0 degree centigrade or same amount of ice at the same temperature, giving the explanation. So we know now that water has more heat energy as compared to the ice at the same temperature, same amount of ice. And why does that happen is because ice gains energy to convert into water. So obviously as it is gaining energy to convert into water at 0, so ice has lesser energy and water will have more energy. And we'll write this as the ice to convert into water absorbs the latent heat of fusion, that is heat energy, to convert into water at 0 degree centigrade. Hence water at 0 degree centigrade has more energy as compared to particles in ice at the same temperature. Okay, so with this we will end today's class. In the next class we are going to discuss about the second effect that matters in the change in state. First was change in temperature. The next one is going to be change in pressure. So that we'll be discussing in the next class, and also what evaporation is. Thank you.